Hello, everybody. My name is Mike DiPetrillo. By way of introductions, I work at VMware. I run all things blockchain at VMware. Throughout this session, you're going to see a few different people up in the front of the room here and up on stage. I'm lucky enough to have some partners with me that I'll introduce throughout the session here, because we will be doing actual demonstrations of useful use cases on top of blockchain, not just sitting here going blockchain, 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 like my compatriot just told me to do for 2 hours. So I won't set that record. I will talk about blockchain. In this session, we are going to talk about VMware Blockchain quite a bit, especially towards the end of the session. It was announced this morning, so who made it to the keynote? All right, who stayed awake through the keynote? Fewer hands. Okay, I'll have to tell Pat to talk louder next time. So with that introduction, we'll get to the lawyer slide. Click. There's the lawyer slide, blah, blah, blah. All right, on to blockchain. Blockchain is all about trust. At the end of the day, it's about the trust of that data, but it's about trust. And you're going to hear me use the words trust over and over and over again. And really, it's about decentralized trust. What do I mean by decentralized trust? Well, we all know databases, right? So let's take a look at this compared to a database. A database is all about centralized trust. If you trust the person that's maintaining that database, there's usually a single entity or a single company maintaining that database. If you trust them with the data, if you trust them to back the data up, if you trust them to not manipulate the data incorrectly, then please use a database. Save myself some time, right? I won't have to talk to you about blockchain. But if you're in a case where you have multiple different companies that all want to see the data, all want to write to the data, and they don't necessarily trust each other. Like if you take separate banks, they trust each other enough to do business with each other, but that's about as far as they go. How do I know that other bank is going to do the right thing with my customer data? How do I know that they're going to keep this account information right and accurate? If you end up with that decentralized trust foundation, then that's where blockchain really excels. So database is about the central trust. Blockchain is about this decentralized trust. But it all comes down to that trust of data. That's the foundation for what we're going to talk about today. This clicker. So what does blockchain promise to do? I get asked this question a lot. You know, I've been talking blockchain a lot to a lot of different customers all around the world for a few years. And I always say, you know, they ask me the very first thing in the Meet the Expert session, right? That was our very first question. What will blockchain allow me to do? I hear a lot of things that blockchain will allow you to do. It's going to make you a billionaire, right? Why play the lottery? You just go out and buy one of these cryptocurrencies, you can be a billionaire tomorrow. Or better yet, just write a white paper tonight, go and do an ICO tomorrow, you're going to be a billionaire, right? I don't know if blockchain is really going to do that for you. So let's skip that. We're not going to talk any more cryptocurrency here. The other thing is that I hear that blockchain is just going to solve your problems. Put blockchain in here, it's going to solve my problems, it's going to solve world hunger. I've heard this quite a bit. We want to do blockchain. Well, why do you want to do blockchain? Because it's going to solve this problem. And you hear some weird problem, and it goes back to this central authority or this decentralized state. Blockchain's not going to solve your problems just by implementing blockchain. So be careful in your selection of use cases. And we're going to talk about use cases here in just a second. I know Dilbert always gets the screenshots. I don't know why. Blockchain, again, is about that trust of data. How do you trust that data? How do you trust that everybody's behaving correctly with that data? It's about that decentralized trust. It's about reaching consensus with that decentralized trust. So I thought I'd drill trust into your head several times. Now the nice thing about trust in this decentralized state is everybody gets this same copy of the data. Right? If you think about it, blockchain at the end of the day is a large peer-to-peer network with guaranteed delivery to every single node. Everybody gets a copy of the data, and you know no one's mucking with that data because everybody has to reach consensus to do that. So this leads into our first use case. I've asked a bunch of people, you know, what are the use cases? I've collected, I don't know, 287 some odd use cases. I know our partners have collected well over 400 use cases each that they've done. But blockchain is really good at 4 things. These are the 4 things. The first is guaranteed and verified data dissemination. Like I just said, everybody gets a copy of the data. Now what's nice about this is that auditors and regulators for the first time can really participate in stream with this data. If you need to say, hey, I have a mandatory disease reporting law, and I want to make sure that everybody has a copy of this disease that this person just got so that they can, you know, figure out if they're going to cause an outbreak, a regulator can come in and say, hey, I'm going to participate. I'm going to get a blockchain node. I'm going to receive that data. And as soon as I receive that data, I know that every other person in this environment received that same data, and everybody's on a level playing field. Yesterday in my IoT talk, I talked about how this can be used to secure IoT devices with certificates. So guaranteed and verified data dissemination is the first main use case. The second main use case is about asset and product tracking. So blockchain, implemented most of the time, has this append-only immutable log. Unlike a database where I say Mike has $1,000 and then Mike gets $2,000, so we just go in the database and we change that one field to $2,000, blockchain doesn't do that. Blockchain says, okay, Mike has $1,000, we're going to write that transaction in a block, it's on the blockchain. And then Mike has $2,000 later, we just say Mike has $2,000 in a separate transaction in a separate block. All those blocks are still there, all the transaction history is still there, and so it's really great to be able to go back and track down data provenance and history. We see this a lot in kind of lot tracking and food tracking. We see this in part history tracking and part provenance. And this will lead me into actually the first demo of the day, right? What's a good presentation without getting the first demo up and running right away? So I'm pleased to bring up Manib Shah from Wipro. Wipro is one of the partners that we introduced this morning during the keynote. He's going to go into the first demonstration of the day. I don't know if you need the clicker, but I will give it to you right here.
Thank you, Mike. I hope I'm audible. Yes. So before I go into the demo, right, what Mike was eliciting to earlier, blockchain is all about trust, but at the same time, you have to select a use case very carefully. Right? Does the use case really entail going on blockchain? Supply chain, you would have heard of, is one of the use cases which is often talked about in blockchain. But supply chain is a wider gamut. So what we have done is we have broken down supply chain into smaller modules, each focusing on a particular problem area. The use case that we're demonstrating here today is about reverse logistics, specifically tailored for the pharmaceutical industry, where they manufacture drugs which go to pharmacies, but then have to be tracked back to the manufacturer and incinerated on their expiry. And that incineration certificate needs to be produced. And this solution works today, but it works in parts. There is no complete end-to-end auditability of this particular process. So what we have tried to do with blockchain today is replicate that process on a blockchain and bring in more efficiencies and trust. So going ahead. So I'm here logging on to the Athena stack of the blockchain, the VMware blockchain. So if I look at the block list now, and if I scroll down, so what you see here actually is sorry, I'll have to go back. So you see here a block in the block list, and this block is basically the block where we have deployed the smart contract. What we showed here is the block contact address and the hash. If we go to the smart contracts, you can see the smart contract source code. You can see the smart contract bytecode, which gets executed. You can also see the smart contract metadata, which contains all its functions and the arguments for those functions. Now, going back to the application for a minute, so what we have done here is basically a pharmacy creates, based on certain parameters, a parcel ID, and you can see the hashes of those parcel ID and the transaction IDs getting created. So this parcel is actually created for the medicines which have expired. A smart contract kicks in, and the back end executes a shipment. The shipper receives it, and the drugs are now passed back to the manufacturer. What the manufacturer here does is they basically create another transaction, which is actually an inbound transaction, basically saying that we have received the parcel of drugs back. And you can see there that there would be, once a QR code is scanned, we create the inbound parcel, there would be a hash generated onto the blockchain. After this inbound is generated, what then happens is the warehouse actually generates an outbound transaction, where you see an outbound created here, and sends this parcel through to the incinerator. The incinerator then incinerates the medicines, and once that is done, it generates a certificate stating that the medicines have been incinerated. Here you can see incineration complete, and you see an incineration complete transaction also coming onto blockchain. You click on View Certificate. It displays the certificates that the medicine has been incinerated. Now, this is what we have done here is we have simplified the process. It's a more complex process than it seems. But now if you look at, again, the Athena blockchain stack, what you see here is a lot of blocks that have got created simultaneously, which were initially just 2. Within each block, you can see the success. Within each block, if I click now, you can see the transaction details, and you can also see the status of that transaction as a success. So what we have done here is achieve that end-to-end transparency with respect to the parcel moving from the pharmacy through to the incinerator, creating the certificate, making that available onto the blockchain. As a part of this particular demo, we have just used one smart contract, which we are displaying now. And we have used 4 nodes. It's a 4-node configuration. And you can also see the status of the nodes as healthy in this particular demonstration here. So a very classic case of where blockchain comes to use and aims to solve an industry-wide problem which is prevalent, and we can bring about a more sustainable solution for that. Thank you so much. Happy to take any questions afterwards the session. Thank you, Mike.
Thank you so much, Maneeb. So that's a real, actual application being used today to track drugs, make sure that they're incinerated correctly, live, sort of pseudo-live. We decided not to pray to the demo gods this morning and record these videos instead on the Vmware blockchain. There's many, many different applications you can use on blockchain, but that with the data provenance gives you great tracking history throughout the solution. So we went through guaranteed and verified data dissemination. Asset and product tracking was our second case. The third case, if my clicker ever works here again, is asset transfer. Blockchain prevents something called the double spend problem. Once I've presented a proposed right and it's reached consensus, that asset, whatever that asset happens to be, drugs, this chair, the water bottle that's on the table, whatever the asset happens to be, it's transferred. I can't then again transfer it to somebody else. This is what gives us that strong certification that once this drug has been stamped and certified to be incinerated, it's stamped and certified to be incinerated. We can't unincinerate it and go and sell it off to somebody else, right? So that's the power of blockchain, is that it gives that data to everybody. Everybody knows they have that same copy. With asset transfer, we can unequivocally say that we have transferred that asset, and it cannot be transferred or untransferred, I guess, is the new word I'm making up. So the fourth and final use case is certified claims or verified claims. You are who you say you are, or you have what you say you have. We see this a lot in KYC and banking. We see it in digital transcripts in education. You know, for example, how do I know that Mike got a degree in underwater basket weaving from MIT? Well, I have to call up MIT, right, and say, hey, did Mike get this degree in underwater basket weaving? They said, no, he actually got a degree in advanced pet sitting, right? I didn't know MIT actually had those degrees, but apparently they do. So, you know, Mike has this degree, but everybody has to call it up. Everybody, you know, anytime I go and get recertified or re-verified, I have to call up MIT. They get tired of answering these calls, especially about their advanced pet sitting degrees, right? So instead, we can say MIT is going to stamp and certify and attest to this thing on this blockchain, and now anyone that I need to provide this information to, they can see the origination source that MIT, yes, they stamped it, it's in this particular block, it can't be changed, it's immutable, it's trusted, everybody has a copy of this, and it speeds that whole process up. So the certified claims is actually jumping into kind of my number one use case in my category list that's here for where we end up engaging. Now you can take all 4 of these things and you can combine them into something more complicated. You take like supply chain, we just saw a supply chain or reverse supply chain use case in this particular case, right? But you can combine these things. So we have data distribution, for example, sending out warranty information or recall information or product documentation from the producer to the consumer. We see product tracking at the top. You know, the consumer wants to know when is my good shipped or where is my part or anything like this. We see the transfer of assets back and forth. We see the auditors sitting in stream to verify that that information is happening. We see certified claims and inventory checks coming back and forth. So we see those 4 main use cases being combined and merged into something larger like a full supply chain use case. So to show you another demonstration of how this works in action, I'm going to bring up, these clickers drive me nuts, Jack Kiernan from Deloitte to show you the next demonstration. All right, Jack, I'm going to actually flip the little port over and wake your laptop up, maybe.
Of course.
Maybe not. Here's where the demo gods get us. Here, I'll go back to this while you log in.
Thank you.
If you log in. All right. Wow, your password is pet sitting. It matches my degree. That's awesome.
It's the Kanye password. All zeros. Thank you, Mike. Again, my name is Jack. I work at Deloitte. I'm excited to be here and partner with VM. Excited to partner with VM to bring blockchain to reality. I think we've, over the past few years, seen great interest in the space, but actually bringing it to production and making it live. It's an exciting time in blockchain. I'm going to stick with the supply chain theme of the day, and I'm going to play a quick video to set the context.
Today's supply chains are increasingly complex and span across borders. Yet most companies still rely on paper-based processes. This can mean time-consuming, manual, inefficient, and costly processes for all parties. Low traceability in a fragmented system can result in safety issues, counterfeited goods, and inconsistent data. At the same time, consumers demand more and more transparency about the origin and quality of the products they buy. So isn't there a better way? Track and trace. Deloitte's blockchain-powered solution can help you to reduce processing time and track physical goods on a digital ledger. Each transaction indicating a movement of goods is recorded, from raw materials to the finished product, which helps ensure a transparent and secure way of tracing products in one shared ecosystem. Retailers, suppliers, and manufacturers collaborate on the blockchain platform to create an immutable chain of custody. And that's not all. The platform can be integrated with existing enterprise systems and even asset tracking tools. Excited to unlock the potential of the blockchain? So are we. Track and trace, only at Deloitte.
So with that, you've seen a genericized version of what blockchain can do. We're currently implementing variations of this platform across oil and gas, telecommunications, shipping, and retail clients. And to the points raised earlier that this is a nuanced process, and each industry has its own requirements, whether it's pharma or whether it's military aircraft, parts providence, et cetera. So we've tested this. We've built it on several platforms. We've built it on Hyperledger, Ethereum, et cetera. But what we found is, out of the box, these technologies lack inherent scalability. And certainly excited to work with the folks at VM and their new solution, allowing for higher throughput and scalability. So again, making this real. And I don't want to over-index on the process, but again, I'm going to pull up the actual demo of the track and trace solution built on Concord, the Athena stack. And I'm not going to walk through the full cycle because I think Munib did a good job of explaining how the overall process works. But in much the same way, we're tracking each constituent piece of the process, recording it to the blockchain, and allowing for those additional business benefits and processes to be bolted on. So this was an example, and it was a processor taking raw materials, in this case it's tomatoes, and producing a final retail product. So we'll take an example of one of these histories. And as you can see, we have each individual piece of the supply chain denoted on the blockchain with corresponding hashes and indications of what part of the process we're addressing. In addition to recording all this information, it's important that we're able to extract information and draw business conclusions and analysis from it. So with that said, we'll dig a little deeper into one of these transactions. And as you can see here, we have the retailer on the one end, the manufacturer, and then the two suppliers. So this is an example of some of the visualizations that we can provide. And then on top of that, we've also done a visual of the movement of the product. So here you can see from where the tomatoes came, where they were manufactured, and where they were finally sent to the retailer. Again, excited to work with VMware, and happy to be here and answer any questions you all might have following the session. Thank you.
Awesome. Thanks so much, Jack. So you've seen two real live applications on VMware Blockchain. Now, both of these companies were able to do this largely in part because VMware's blockchain is compatible. And what do I mean by this? Well, let's get into what customers keep asking us. As I went around to customers, I heard some very common things with their blockchain implementations. Hey, this is a hosted solution I'm using from this other blockchain, which is great, but I really want choice in clouds, or I really don't want to be locked into a single blockchain provider. I need some compatibility. Or this current blockchain is not performing the way I need to. It doesn't scale the way I need to. It doesn't provide the number of transactions, or I'm getting stuck on the time to finality. So you hear a lot of these things over and over and over again from customers. And so we started architecting the VMware blockchain, which is built on open source Project Concord, to meet some of these needs. This is what we announced this morning. VMware Blockchain is currently in beta. You can go to vmware.com/blockchain to learn all about it, to sign up your interest in the beta. And it's really built around three centralized thought processes. It needs to provide enterprise-grade decentralized trust. What do we mean by enterprise grade? We mean that you need to be able to scale this thing to hundreds or thousands or even millions in the case, in some particular cases, of transactions, of nodes. You need to have quick time to finality. It needs to work in an enterprise setting. It needs to be able to have audit tools built around it. That's what we're talking about when we talk about robust day 2 operations. Day 1 is stand up, configure, here's your blockchain, congratulations, go have fun. That's the way most blockchains operate today. Day 2 is what happens when I need to do an audit on this? What happens when I need to remove data from this blockchain and provide, in a regulated environment? What if I have data sovereignty issues? I need to lock down data to a particular geographical location. This is the stuff we concentrate on and from a VMware blockchain perspective. And it needs to be developer friendly. I need to have tools that I'm familiar using. I need to support the ecosystem that's out there from a developer perspective. All rooted on something called Project Concord. So let's break down each of these things. First of all, VMware Blockchain is a hybrid cloud SaaS solution, or a hybrid SaaS solution, meaning we can deploy it on top of, right now, IBM Cloud, so VMware on IBM Cloud, or VMC, VMware Cloud on Amazon Web Services, or managed on-prem nodes. Now, VMware has over 4,000 cloud partners, so we'll continue to expand this ecosystem to where you can truly get decentralized trust by deploying across multiples of these cloud providers that's out there. And that's the second point. In order to get that true decentralized trust, you need to deploy these nodes away from each other. You need to have multiple places where you can provide that trust. VMware is in a unique position to offer that capabilities. You need to have better scaling and throughput. We hear this quite a bit, that people go into kind of this pilot or proof of concept. They're out there, they have their 10 consortium members and maybe 6 or 9 nodes deployed, and then they realize, hey, next month or next year, I'm going to have 50 members in my consortium or 100 members in my consortium. And there's no way that I can currently scale with this current node layout. Or I can't get the transactional throughput that I need. Or something called time to finality. How long does it take until this is actually certified and written in the blockchain? A lot of the mining-based solutions or proof-of-work-based systems that are out there today struggle with that. You could have 2 people solve this cryptographic mining problem near the same time, and then they both write to the blockchain. And what happens is the blockchain forks, right? And both blocks get written. And I have to wait a period of time for one of those chains to get a little longer than the other, and then it wins. So if Jack had written to the short chain, and Manib had written to the long chain wins, guess what? Manib's transaction is the one that wins and gets written. Jack's out of luck. His transaction never happened. This could take minutes, hours. I've seen it even take days in some circumstances. This just is prohibitive to enterprise applications. So one of the tests we recently ran is to do some benchmarking. Now this is just an initial benchmark. We'll have a blog post so that you'll be able to recreate this. There's a voting application that's actually out here in the Europe somewhere. We snagged it from. I'm looking at the engineers down here in the front corner. They're the people that did this. So we grabbed this voting application that just throws thousands and thousands of votes at the system to benchmark this. And we benchmarked it originally against Ethereum. We support the Ethereum virtual machine on top of our platform, so it's really easy to take Ethereum-based applications and run it on our platform and Ethereum in kind of a heads-to-heads kind of comparison. And what we'll see is that as we threw transactions to this was actually 16 nodes of Ethereum, 16 nodes of VMware Blockchain, threw 1,000 transactions at it. Our total throughput on the VMware side was around 444, this magical number from a VMware perspective. I had them triple check that one. It's an interesting number to come up with. Versus around 21 for the public Ethereum. And this is pretty typical throughput for, or not public Ethereum, but for our 16-node Ethereum setup. Time to finality was also much better. You'll see this when you go through demos or if you go to our hands-on lab. You'll see that as you go through and transmit blocks or commit transactions into blocks, that it's near instantaneous response that comes back to you. And these are finalized responses. So the finalization that happens, because we use something called Byzantine fault tolerance, which is a voting-based system instead of a mining-based system, actually is much, much better. So time to finality is a huge thing. You'll also see that CPU usage, because we're not doing mining, is much, much, much lower. And I'll show you a slide in a second on what the impact of this is. So throughput, enterprise-grade throughput, this solves actually a good deal of throughput problems for people. And we've, benchmarks are one of those things where I can look at you with a straight face and say, we get these numbers. I can look at you with a straight face and say, we get 12 transactions per second. And I can look at you with a straight face and say, we get 45,000 transactions per second. So benchmarks are weird. I'm caveating this, this slide heavily, but again, we're going to publish a blog post with how to run this in your own environment to see sort of what you get out there. So scaling and security are very, very, very important. And that's the main underpinnings of VMware Blockchain. We concentrated heavily on security. That's why we created a scalable Byzantine fault tolerant system. And we concentrate heavily on scaling. Scaling was so important for Verizon. They were one of the customers up there that was on our keynote slide. They were talking about how do I manage and operate and bring in the transactions from around 280 million IoT devices, right? So I mean, this is high scale, high throughput kind of scenarios that we're doing. So main key concerns for Verizon and the reason they're going VMware Blockchain right now. We also, from that day two operations, concentrate heavily on auditing. We get into these regulated environments a lot, and pretty much everywhere is a regulated environment. I need to do a HIPAA audit on this thing, or I need to deal with GDPR compliance, and the right to be forgotten. I need to go and do some sort of audit on here, a PCI compliance audit check, because I'm dealing with, transactional financial data. How do I do these audits on a blockchain? Well, that's fairly easy. We can see the transactions. We can have these audit tools. But then all these other nodes are replicated out there. And then how do we know that other partner that I'm working with in this consortium that also now has that data is doing the same thing, that they're providing the same framework? So some of the partners and I, we talk about this quite heavily, how do we deal with a decentralized audit of sorts? So we're building a lot of that into the VMware blockchain interface. As I mentioned, we support the Ethereum virtual machine on our blockchain platform today. This unlocks that potential for the 6.5 million Ethereum developers that are out there in the development community. It also allows us to tap into that rich ecosystem of application vendors that's out there in the Ethereum industry, but it doesn't stop with the Ethereum virtual machine. One of the powers of how our blockchain was architected, and one of the wise decisions from our engineers, was to abstract the different components that are in here. So you have a consensus layer that it's actually abstracted from our persistence layer, our replicated state machine that's out there. So you can provide other replicated state machines. The state machine is just arbitrary. We may choose to do it via blocks one day. We may choose to use some other type of replicated state machine in the future. There's also an abstraction layer to the languages layer. So the Ethereum virtual machine was the first one that we implemented on the system, but there may be other languages that come along. The Ethereum community has been working on eWASM support, so Ethereum-based WASM support that we could put on the platform. Might be Java down the future. We might do something with other interesting languages that go on top of the platform. But it's about giving you that choice and about giving you that flexibility that's inside of the environment. So very, very great architecture from a VMware blockchain perspective. All this, like I said, is rooted on something called Project Concord. So all the stuff that we just talked about, the scalability, the enterprise security, the Ethereum virtual machine support, all that stuff is actually open source. It's out there on GitHub today. You can go out there and find it. It's linked off vmware.com/blockchain. You can run hundreds of nodes or thousands of nodes if you want to, and go and deploy yourself a blockchain. So there's no kind of limiting it or anything inside of this open source project that's out there. Contribute back, fork it, use it. It's a friendly Apache 2 license. We did that on purpose so that anybody could use it and consume it and not have to worry about tainting their own projects. Energy cost is something that's often overlooked, but enterprises are starting to pay more and more attention to this. If you look at mining-based blockchains that are out there today, they use an insane amount of energy to do what they do, right? There's all this CPU hashing. You have to buy specialized equipment sometimes in order to have that offload engines in there. This is not sustainable. My boss is actually on the record for calling it immoral. Pat's actually echoed this now several different times, and I kind of agree with him. To put this in a little bit of context, now this is a little bit of an extreme. In the top right-hand corner, you have Bitcoin. So this is a public blockchain that's out there, one of the first kind of commercial available blockchains, or not commercially available, but first real implementation of this. They currently rank 41st in world energy consumption. Actually, this is an old slide. They rank 32nd right now. But in this slide, 41st, they're just ahead of Chile and just behind the Czech Republic in energy consumption, annual energy consumption. So think about that. Anybody from the Czech Republic? Great country, right? They're just behind you in energy consumption. Every time you transact a Bitcoin, every time I give Jack a Bitcoin, that uses 1,000 kilowatts of electricity. I give Manib a Bitcoin, that just used another 1,000 kilowatts of electricity. Now, 1,000 sounds like a lot. This is my home in Florida in the United States, a household of 6 people. I use 43 kilowatts of electricity a day. They're using 1,000 kilowatts of electricity for a single Bitcoin transaction. That is immoral. That's not sustainable. Especially working at a company like VMware, you heard Pat this morning, the very first thing he talks about in the keynote is sustainability, our carbon neutrality, the fact that we're going to be 100% on renewable energy. I think our target is 2020. So this is very near and dear to our heart, to provide you a blockchain that can scale, that can be secure, and that's not going to destroy the planet that we live on at the same time. So when you go down here, we kind of check all those boxes, over and over again. We solve the scalability problems and the security problems that people are having. We give them the day 2 operational stuff that they want. We give them the ability to deploy in multiple different clouds. We give them the ability to not be locked into kind of a single blockchain platform. We're open source. There's already forking and consumption of our core SBFT protocol and several of the other leading blockchains to provide some multi-blockchain capabilities here. So what does this look like from a stack perspective? Now, I know a bunch of people are going to take pictures of the next few slides. Don't, because we're going to have to smack you on the way out. No, I'm just kidding. Take as many pictures as you want, but save it for a few clicks down the road, because the whole stack will be here. This is also being recorded, so you can watch it in perpetuity as well. So this is all rooted in Project Concord, that open source blockchain that I just talked about. That's our core blockchain platform. So as we continue to innovate on scale, on security, on other things that we put into our blockchain platform, that rolls into that open source blockchain. So again, use it, innovate on it, consume it, contribute to it, enhance it. That is that core blockchain. So it's kind of this open core model if you want to. Along the side of that, we build management and security tools. Some of this we integrate into existing VMware tool sets. VMware infrastructure powers, I think, like 99% of the world's digital infrastructure these days. So we're integrating it into those tools. So if you have Wavefront that you're managing, you'll be able to see and manage and operate our blockchain at scale, or Log Insight. We've integrated with technologies such as NSXT to provide microsegmentation and Firewall. And you heard about this microsegmentation concept this morning in the keynote, right? We were doing integrations in there to protect those blockchain nodes as they rotate through different cloud providers. We did integrations with RSA NetWitness as well, to make sure that integrations. Sorry, this little ding thing went off, and I just thought I lost my phone. This is my little phone sign. RSA NetWitness to do protection against the blockchain nodes, to provide awareness of the infrastructure that's going on there and the processes that are going on there. So we'll continue to innovate in the management and security stack. That's very, very important to us, the day 2 operational aspect. On top of the core blockchain stack, we're providing different utilities. Some of these are partnerships that we partner with people. Some of these are innovations that we do out of our research group, and our core researchers are up here in the front of the room. And some of these are innovations that we'll continue to do. What's important to build on this decentralized trust foundation? What are the tools and the utilities that we're going to need to operate this thing? How do we enhance that? If you take key management, just for an example here, Key management, okay, we kind of got a grasp on that from an IT perspective. We have key management systems, even distributed key management systems that are out there. But who's managing those keys in your blockchain environment? Is it Sally down the hall? Well, there's your centralized authority at that point in time. You're not in that decentralized state. You just broke blockchain, essentially. How do you get to a decentralized key manager? How do you get to the point where I need multiple different people to unlock that key at the same time and allow blockchain nodes in, or allow information to flow inside the system? So key management is one of those areas that we'll continue to innovate on. Or how do we enhance the security of this blockchain? So we've done a lot of research and a lot of investments and partnerships in zero-knowledge proofs. If you're not familiar with zero-knowledge proofs, it's kind of a crazy thing. It's another thing to go and talk about tonight at the dinner party, like Byzantine fault tolerance. Rattle off zero-knowledge proofs, you're going to sound like a rocket scientist. So zero-knowledge proofs is the ability to basically prove to you that I have something without showing you that I actually have it. So for example, you ask me to prove that I have this clicker in my pocket. Well, I'm going to say, yes, I can attest to that because I can show you, I can forward the slide and I can reverse the slide. So obviously I must have this clicker in my pocket or some mystical magical thing. And I do that enough time to get a mathematical proof built around that to show you that I can actually demonstrate that I have something. Now this is really important in blockchain because blockchain is about the trust, this trust of that data. Well, what happens if me as an individual, I don't have to actually put my information out there anymore? You want to know, hey, are you this 43-year-old that lives in Florida? I can attest, yes, I'm this 43-year-old that lives in Florida without actually providing that data. So the data never actually makes it out there. It's kind of one step beyond blockchain. Without actually putting the data out there, I can attest to that and prove that. And I can lock that attestation in a blockchain to get to this super high trust of that data. So we're doing stuff around zero-knowledge proofs and have partnered with QEDIT or KEDIT out of Israel in that space. There's a lot of stuff that we're doing around identity management. There's a company called Uport, part of the consensus group of companies out there, that provides sovereign identity, an identity that you can take from place to place to place that's not tied to one particular system or root of trust. They do that by using blockchain. They're an Ethereum-based system, so they're able to port onto our application rather rapidly. We're doing a lot of stuff around multi-blockchain. We know there's not one blockchain to rule them all, so there's multi-blockchain work going on with ourselves and other partners. You'll hear more about that in the future. SMPC, or secure multi-party computation, that kind of, two people turn the key at the same time, multiple people have different parts of the secret and can combine that secret, not all at the same time without exposing their secrets, to operate on trust. So again, taking that trust foundation that blockchain is, what are the tools and utilities that we build on top of that? So you'll see a lot of more work as we go on in the utility space. And then on top of that, you have applications. We just saw an application from Wipro and Deloitte running on top of our blockchain. We have many, many more applications that have been built by other partners, by other ecosystem players that are out there that continue to come. Stuff inside of data dissemination, supply chain, that asset tracking, verifiable claims, IoT security. So you'll see applications come about over and over and over again that continue to be built on our blockchain. Oops, I have an empty slide in there. Deloitte is our first major consulting partner in this space, along with Wipro. Other consulting partners are coming on pretty soon, but the interesting thing is you go and you start doing blockchain, it impacts a lot of things that people typically don't think about. It impacts legal inside of your environment. Now you're doing businesses with a lot of different people that have your customer data or have data that you're sharing, right? How do we protect that stuff? What are the contracts that need to be in place? What are the privacy regulations? And I'm not a lawyer, so don't ask me on the rest of this stuff. Tax. Now you're not doing business in one place. There are tax obligations and tax consequences to using a decentralized trust infrastructure. So think about that. Engage these consulting partners so they can come in and give you this information. And then industry affiliations. We're founding members of the Hyperledger projects inside of the Linux Foundation. We are members of the Enterprise Ethereum Alliance. We're members of a group called IC3, which is an academic consortium that's out there. We try and drive as many innovations and as many thoughts as we can through the community. Blockchain is one of the first places. I mean, I've worked in emerging tech for 26 years, right? And blockchain is one of those first emerging techs I've worked with where everybody really works closely together. People that you thought were competitors really try and share and collaborate to drive this forward. A lot of that goes on in standards organizations where we participate. A lot of that goes on just between companies saying, you know, we've got to figure this out, and if we can all make blockchain more successful, it'll move the industry as a whole forward. So we see this as the common good kind of approach. And you'll see that over and over again. A lot of companies that you would think wouldn't stand on stage together, actually working together hand in hand in this blockchain space. So now you can take a picture. That's kind of the larger blockchain vision and what VMware Blockchain really means. VMware Blockchain is not a single product. VMware Blockchain is our vision for all things blockchain that are happening from a VMware perspective. So I'll give you a second to I see a bunch of cameras. Clicky, clicky, click. All right, moving on. So why VMware? I hear this question over and over and over and over again. You know, I've heard it 3 times today in like the last hour before our session. Why is VMware getting into this space, and why now? Well, it really comes down to 3 things. First of all, VMware is all about solving enterprise-grade problems in a decentralized and distributed trust system, right? I've been here 16 for the 20 years that the VMware has been in existence. And out of that time, if you look at Virtual Center way back when we introduced it, it's about management and security for distributed systems, right? Distributed VMs that are out there. It's about management and security of those VMs. If you look at everything we do in AirWatch, it's management and security for mobile devices that's out there or workplace devices. If you look at stuff we do in vSAN or NSX or really anything that we do, it's all about enterprise-grade management and security for distributed systems and decentralized systems. Guess what blockchain is? It's about management and security of that distributed or decentralized system. So for 20 years, this company has been solely focused on solving enterprise problems for distributed systems, right? You can't point to another company that's all that they've done as a company. Now, sure, they dabble in this and that, but we are solely focused on solving this problem. It's in our DNA. It's in everything that we do, right? So that's a strength from a VMware perspective. The second thing is something I talked about earlier. This is about decentralized trust. We firmly believe that to really get to that decentralized trust and a high-value decentralized trust, you need to put these nodes in multiple locations on multiple different cloud providers. We have over 4,000 cloud providers in our cloud provider program today and growing. A great place to put all these different blockchain nodes that happen to be running. Multiple consortium members may have different cloud providers as well, and they need to collaborate together. So that's a second powerhouse from a VMware perspective. You're not going to get that from another blockchain provider. They're going to say, IBM's going to say, hey, deploy it in our cloud. And Amazon's going to say, deploy it in our cloud. They're not going to say, go deploy it in each other's clouds kind of thing. And then last but not least, cannot be understated, is we have over 4 years of research in this, and we have the world-renowned leaders in blockchain research working at VMware. I'm very privileged and honored to be able to work with these people on a daily basis. We have some of them up in the front corner, so you can come and hound them afterwards. But Itai Abraham, Guy Galangueta, and Dalia Mulkey are these 3 researchers that started kind of this blockchain research at VMware 4.5 years ago. They are the leaders in this space. If you go and look at who's innovating and who's kind of the point of the spear in the research and blockchain space, these are the names that are going to come up over and over and over again. These are the people that you're going to find at these conferences doing stuff over and over and over again in this space. We happen to get lucky enough that they work at VMware, but it can't be understated that we have the ability to innovate in this space. It's core to what VMware does. It's core to our research program that we have as part of the blockchain group. This decentralized trust is near and dear to our heart. So with that said, if you want to know more, vmware.com/blockchain. There's also an email address, blockchain-info@vmware.com. There is a hands-on lab. It's free to take. You can find it online. You can also find it in the lab room over here. If you do it in the lab room over here, you're able to raise your hand, and we have some blockchain experts that roam the room, so you can ask them good questions and get good insights. You can find me around the show roaming about here and there, as well as some of the other individuals that are on my team. If you guys can just stand up, Brian, Itai, and Guy, just stand up for a second. At least they know who you are. Find one of these people as well. They're on the blockchain team. So, yeah, thank you. See? That's awesome. Thank you all for doing that. And thank you. One last reminder I think we have on here is fill out your surveys. They're very easy. You just put all 5s down the right-hand side, and then you hit submit. And with that said, thank you for hanging out. We'll talk to you later.